You know, in math, it's often the simplest tricks that are the most powerful. So today we're going to dive into a technique from Baker's math class that honestly feels a little bit like magic. It's a method for solving problems that can sometimes take minutes and doing it in just a few seconds.
Come on, we've all been there, right? Staring at some linear equation, just totally lost, wondering where to even start. But what if the secret wasn't about adding more complicated steps, but about taking something away? What if you could find the answer just by covering part of it up?
Okay, so this secret weapon, it's called the cover-up method, and it is as simple as it sounds. You literally cover up part of the equation with your thumb, and boom, the answer practically jumps off the page at you.
Okay, so to really get how this trick works, we've got to talk about intercepts first. These are just the fancy name for the points where a line crosses the x-axis and the y-axis. Now, here's the key, the big insight. At these exact spots, one of your coordinates is always 0. And that right there, that's the whole secret sauce behind this shortcut.
The guide we're looking at actually calls this the zero trick, which is a pretty cool name. And the logic is just so simple. Think about it, right? If you're standing on the x-axis, how far up or down have you gone? 0. And if you're on the y-axis, how far left or right? 0 again. So, to find one intercept, you just make the other variable 0. Make it disappear.
So this all boils down to one simple, powerful mantra you just need to memorize. Ready? To find the x-intercept, you set y to 0. To find the y-intercept, you set x to 0. That's it. That's the core of the whole thing.
All right, enough talk, enough theory. Let's actually see this thing in action. Let's put the trick to work.
Okay, here's our first example, a nice clean one right out of the study guide. 2x plus 3y equals 12. Our job is to find the 2 points where this line hits the axes.
Okay, so here comes the magic, the cover-up method. To find the x-intercept, we're literally going to take our thumb and cover up that 3y term. Then to get the y-intercept, we'll do the exact opposite and cover up the 2x term. So, imagine you've covered up that 3y. What are you left with? Just a super simple equation, 2x equals 12. A quick division tells you, of course, that x equals 6. And since we're looking for the x-intercept, we know the y value has to be 0. So our first point is 6, 0. Easy, right? All right, now let's do the other one. Cover up the 2x, and what do you see? 3y equals 12. Divide by 3, and y equals 4. That means our y-intercept is right there at 0, 4. And just like that, we have our 2 points. Look at that, no complicated rearranging, nothing. Done. Okay, you ready for another one? Let's try something a little trickier. This one has a negative sign in it, and this is where people mess up all the time. The equation is 4x minus 2y equals 8.
And listen up, because the study guide gives us a huge warning right here. When you go to cover up that x term, that little negative sign in front of the 2y, it doesn't disappear. You have to keep it. That is the single most common mistake on these problems, so don't fall for it.
All right, first let's do the easy part. To find the x-intercept, we just cover up the negative 2y. We get 4x equals 8. Divide by 4, and x is 2. The point is 2, 0. Same as before.
Okay, now for the part where you got to be careful. We cover up the 4x, and we are left with negative 2y equals 8. See? That negative sticks around. Divide 8 by negative 2, and what do you get? Y is equal to negative 4. Our second point is 0, negative 4. See how that one little sign completely changes the answer?
So what happens when the numbers don't divide all nice and neat? I mean, in the real world, and let's be honest, even in algebra class, the answers aren't always pretty whole numbers. Let's take a look at 3x plus 5y equals 7.
We use the exact same method. No change. We cover up the 5y to get 3x equals 7, so x is 7 over 3. Then we cover up the 3x to get 5y equals 7, so y is 7 over 5. Fractions are perfectly valid answers, you guys. They're just points on the line, same as any other. Don't let them scare you.
So now we know how to use the method, which is great. But the guide also points out a couple of super common traps. Let's make sure we know how to sidestep those.
Okay, this is probably the #1 mistake people make. With an equation like, say, 2x plus 3y equals 6, it's so tempting to just look at the 2 next to the x and think, oh, the intercept is 2. But no, you have to actually do the division. 2x equals 6 means x equals 3.
Always complete that final step.
In the other trap, it's just mixing up which variable to cover up. But there's a super easy way to remember this, right from the guide. Just think of it as opposite day. To find the x-intercept, you make y disappear. To find the y-intercept, you guessed it, you make x disappear.
Okay, so why should you care about this? I mean, why is this shortcut so useful? Well, it is fantastic for solving real-world problems, especially anything with a budget or some kind of limit. Let's take a look at a party planning example.
Let's say you've got a budget, $100, that's it, and your job is to buy pizzas for a party.
All right, so large pizzas, that's our x, cost $20, and small pizzas, our y, are $10. Our budget gives us this equation, 20x plus 10y equals 100. This is a perfect setup for our cover-up method.
So check this out. This is where it all clicks. The intercepts basically show you the extreme options for your budget. The x-intercept, 5, 0, means you blow all your money on large pizzas. You get 5 large and 0 small. The y-intercept, 0, 10, is the other extreme. You buy 10 small pizzas and 0 large ones. The intercepts define the absolute limits of your spending.
And here is the really cool part, the final takeaway. This zero trick, it's not just for lines. It works for finding intercepts on parabolas, circles, all sorts of more complex curves. It's a fundamental idea. So it makes you wonder, right? What other simple, powerful ideas are just hiding in the math you think you already know? Thanks for tuning in.